Hello, today we're going to look at the laws of logarithms, and we're going to use some generic methods in order to derive the laws, and then we'll use those laws to answer some questions. So number one here, determine an equivalent expression for log base A is m times n, where a, m, and n are all positive numbers, and a cannot be 1. So in order to do this, we are going to say let m be equal to a to the power x. So what that means in log terms is x equals the log of a is m. Okay, and then we're going to say let n be equal to a to the power y. So y is equal to the log of a to the power n. Okay, and now our only variable is a. We have some experience, well, we have x and y, but of a, m, and n, everything is in terms of a. So we can conclude here that m times n means the same thing as a to the power x times a to the power y. And we know through our product law, our exponent laws, when you're multiplying the same base with exponents, we add the exponents. So a to the power x plus y. Okay, now let's look at the equation that we've been given. So log base A m times n will be equal to log base A of a to the power x plus y. And since we have log base A is mn equals log base A of something else, we know that m times n will just become equal to x plus y. Or sorry, because we know that log base A and the base of the exponent is a, sorry, it will equal x plus y. And now we look back to the left side of the screen here, we see x equals log base am and y equals log base an. So let's substitute those in. So we have log base am plus log base an. And that's our first law. So therefore, the log of base A m times n is equal to log base am plus log base an. That's going to be an important property going forward. Okay, number two, determine an equivalent expression for log base a, but m is divided by n. Okay, so we're going to do the same thing. Let m be equivalent to a to the power x, which translates to x equals log base a to m. Let n equal a to the power y, which translates to y equals log an. And again, through our exponent law knowledge, we know that m divided by n will be a to the power x divided by a to the power y, which equals a to the power x take away y. Okay, and we're going to do the same thing, go to our original equation, plug them in, and substitute our x and y. So we have log base a, this time equals m over n, is the same thing as log base a to the power x minus y. And since our log base and our exponent base are the same, this becomes x minus y. And we are going to sub in, so log base a m minus log base a n. And therefore our next law is m over n is equivalent to base a, whatever m is, take away log base a, whatever n is. Okay, another important property. So if our log bases are the same, we can subtract. Determine an equivalent expression for log a m to the power n. This is like our power law that we had from exponential laws. Okay, so let's let m equal a to the power x, which means that x is equal to log base a m. Actually, we don't even have to let the n because it's not a log n. So we have m to the power n in our original equation is equal to a to the power x times n, or to the power n, which becomes a to the x times n. That's what I meant there. So a to the power x to the power n becomes a to the power n times x, or x times n. Okay, so we have log base a m to the power n is equal to log base a of a to the power x times n. Okay, so that becomes x times n, which is log a m, because that's what x equals, times n. Okay, so therefore this is log base a m to the power n. If we have it like this, it'll be n times log base a of m. Okay, so three important laws. Let's write them at the top of this page so we don't have to keep flipping over. Log a of mn is equivalent to log a m plus log a n. 2 log a m over n equivalent to log a m minus log a n. And 3 log a m to the power n is n times log a m. Okay, so there's our three laws. Let's calculate some. So number 4, simplify each log expression. So we have log base 3 to 6 plus log base 3 to 4.5. So we have the same bases. We're adding, so we're going to work backwards here. The only one of our three laws at the top that has log something plus log something is law number 1, and we're doing it the backwards way. So this is going to be log base 3 6 times 4.5. This is the log a m times n. Okay, so log base 3 6 times 4.5 is 27. Okay, now we convert this into exponentials. So it says 3 to the power x equals 27. And we know that 27 is the same as 3 to the power 3. Therefore, x equals 3. Okay, B, this is a subtraction one, so we know we're working with law number 2. So this is log base 2 of 48 divided by 3. So log base 2 of 16, which is the inverse of 2 to the base x equals 16. And we know that 16 is the same as 2 to the power 4. Therefore, x equals 4. Okay, and now we have an exponent. Let's go green here. So we have log base 5, and the cube root of something is really an exponent of 1 over 3. Okay, so using our law, that's the n part, so the n is going to come in front, and log base 5 of 25. Okay, log base 525 is 5 to the power x equals 25. So you see we're leaving this 1/3 out in front, the n part of our law. 25 is 5 squared. So now it's 1/3. So x equals 2. So the answer here will be 2/3. Express log base 2 to the power 4x squared divided by the root of y in terms of log base 2x and log base 2y. Okay, it's a bit tough. We have log base 2 4 plus log base 2 x squared minus log base 2 square root of y. And we know that the square root of y is really y to the power 1/2. Okay, so if you don't quite understand, so our numerator is 4 times x squared. So that's law 1, where we separate the multiplying into 4 and x squared, and we're adding them. And then we have it divided by, which is the minus that we see in what we've drawn here. And we're minusing the square root of y. Okay. So this first part is asking us 2 to the power what equals 4, and that is 2. 2 to the power 2 is obviously 4. I don't like how I wrote that 2. Okay, the next part, okay, so we just did this. The next part, we have 2 to the log base 2 with an x squared. So we have an exponent there, so we're going to bring that 2 out here, and it's log base 2 to x. And again, we have an exponent because the root of y is y to the power 1/2. So we put the y in, or the 1/2 in front, and we have log base 2 y. And we can't change those because the x and y, we don't know what they represent. So this is the expressed term. Okay, a change of base formula. Let's work with log base A to C. We're going to change the base to log B. So it's log base B of C divided by log base B of A. So this is a change of base formula. And this will be the same as if we had y equals b to the power x. X would be log y divided by log b. Okay, so we looked at this before. In order to find the exponent, we do the log of the number without the exponent divided by the log of the base. Well, it's the same with logarithms. So if we have log base a and the answer would equal c, it'll be a log of base b to c divided by log base b to a. Okay, those are the log rules that we'll be working with.